So, hello everyone and welcome back to another video. And today I'm going to solder again. And this will be the same mod that I showed previously. I'm going to attach VCore Voltage Sense lines to this graphics card here. This is the GTX 470. And yeah, so now I'm going to show the full process of making it, of how I did my mod, which ended up working. And yeah, so if you have a graphics card and want to attach VCore voltage sense lines and you want to know how to do it, you can just watch this video, because I'm gonna show the full process of how we attach the mod and also the basis of it, so how to find the right capacitor. And yeah, let's just get into it. So first the basics. To even have a chance to find the right capacitor, we need to know the core resistance of our graphics card. For that we will use a multimeter set to resistance mode, and an easy way to find out your core resistance is just by measuring your VCore output inductor and against a known ground. So here we have 400 milliohms. Sometimes it says 500. That is the core resistance of this core here. It's a little bit low for this core actually. Other Fermi based cards like this will measure in the 700 milliohm range, but this card measures 400 milliohms. And yeah, that's the core resistance of this card right here. So now, knowing this measurement, the resistance of the core, we can go to the back and look for a capacitor that also has the same resistance, because it is in the same circuit. So again, we take our known ground, which is right here at the red wires that I soldered to the board. That is just the normal ground connection from the PCI Express connectors, which are standardized, so we always know that is going to be ground. And now we go to the back of the core and we will measure what resistances our capacitors have. So if you have found a capacitor that looks like you could solder to it rather easily, you take your multimeter and measure again. So right here we see that our resistance is lower. It is 100 milliohms, or 0 actually, like that is the ground side of the capacitor. This multimeter doesn't really show 0, it shows 100 milliohms even when things are shorted together. That's just, that depends on how good the ground plane is, what probes you're using, also how good your multimeter is. This is a little bit more expensive, like compared to a usual multimeter you will have, but it's still not a really expensive one. So yeah, that is the ground side, even though it says we have 100 milliohms. So now let's measure the other side of that capacitor, and here we have our 400 milliohms again, which means that this side is VCore and the other side is ground. So we have found a capacitor that we can solder to. You see I've already marked this one because I have this is a reshoot of the video because I messed up a couple times. And yeah, so I've marked this capacitor here with some black, yeah, I've marked this, and now we can start attaching the mod. But first I'm gonna have to tell you that if you're trying to do this with a newer card, for NVIDIA that is GTX 10 series and newer, for AMD it should be Navi based GPUs and newer, you will find that when you measure the output inductor right here for VCore against ground, you will see that most multimeters will show as if it were ground, like as if there is no resistance. That is because as the manufacturing process gets smaller, like this here is still a 40 nanometer GPU, while AMD currently is at 7 nanometer and NVIDIA is at 12, which is a lot smaller. And especially big GPUs will have a really low resistance, which means that a normal multimeter that is not specifically made for milliohm range will not be able to pick up the core resistance. If you have such a GPU, you will sadly have to resort to other measures to find out which side of your capacitor is VCore. You could also just search for a capacitor that shows shorted together on both sides, and as long as the card still works, they won't be really shorted together, it would just look like it. And then you can still attach the two wires, you just won't really know which side is VCore and which is ground. So yeah. But this is a GTX 470, a pretty old GPU, and like 28nm GPUs like 980 Ti's or AMD cards from that time, they will have a measurable core resistance. So for those cards, that's not really a problem. And I guess people who modify cards in such a way will generally have older cards, or will not risk a newer card by doing this. So now where we have that out of the way is I'm going to talk about what I'm going to do now. So we have our two wires here. I've already removed the insulation at the end of them, and one of them is going to VCore, one is going to ground, and we're going to solder those on. You can absolutely just do that, and as long as you take care that your soldering is accurate and that you don't accidentally create shorts, like always check if you have a short with your multimeter afterwards. Again, on newer GPUs, you can't really, because the core resistance is so small, but check if you have a short, because if you short VCore to ground, especially in an area like this where there are capacitors and generally the GPU, if you short VCore to ground there, yeah, you will have a bad time and the card will probably die. So yeah, be careful not to create shorts. Then you can do a little bit more advanced version of this mod, which involves a resistor. This is not really a resistor, this is a fuse. So yeah, this is a 2 amp fuse, but resistors look basically the same. You can use a resistor with like 5 or 10 kilo ohms and attach it to one of those wires. So if you accidentally should short those wires together, like if they accidentally touch each other, you will not short VCore to ground because you have that resistor there. If you want added security, you can put a resistor in. I will not be doing that right now because I don't have a resistor here. I only have this 2 amp fuse, and yeah, I will not be putting that in, since if you accidentally short a fuse, you will have to replace it, and the resistor will just, like, it will make you not short. It will prevent a short, whereas a fuse will just burn out and you'll have to replace it. And if you have cables this small, the cables can also act as a fuse, basically. So yeah, I'm not bothering to solder on the fuse right now. So now we can get to the soldering of the GPU right here. And the first thing that we will do is I'm gonna twist those cables a little bit more together, since this is a multi-core cable. I don't want any of those internal wires going away somewhere and create shorts. So I'm trying my best to twist those together a little bit more. I also try to just put a blob of solder over them so they stick together. So we can yeah, solder to our capacitor right here, which actually it's gonna be more difficult on this card than on the card that I already did it on, because here there are other capacitors the same size nearby, whereas on the other card there were 2 of those style capacitors which have a plastic casing, so if you touch that with your solder, yeah, nothing's gonna happen really. Whereas here we can definitely create a short accidentally. So yeah, this is gonna be a test pretty much. But now let's start the soldering, and I'm gonna have to activate the soldering iron. So now, now we are at a part in the video where I will maybe put in some time lapses, because some of those parts are very easy and just take a lot of time. So yeah, maybe like waiting for the multimeter to get warm. It's pretty hot actually already. So let's first do our yeah, this is very unlucky. So yeah, I had accidentally created a connection to 2 more capacitors. We don't want that. That will create shorts and then you will have a bad day. So I'm gonna check if that other capacitor is still... Yeah, it looks like there is no solder over that little one. So now we have a solder blob right there. Let's try and attach. Actually, I'm gonna bring the camera down a bit so you can see more. Damn, this is difficult. It's still loosely attached. There are some problems that I don't have a lot of light right now. Okay, I'm going to put some light up. Nice. Okay, the wire is attached again. I'm now gonna try to put some more solder on it to really get a secure connection. No, don't fall down. Okay, it is still on there. The blob is a little bit bigger than I would want. But as it looks like, that's gonna be it for now. Actually, I'm think I'm also gonna put up the card up a little bit so you can see more. So here we have power supply box. Now that is a good look. So you can see that the solder blob right there is a little bit bigger than I would want. Maybe I can get some solder onto the wire. Yeah, looks like it's gonna work. Yeah, okay, that looks better. It still could be a little bit. Yeah, so I'm also going to put a hot glue over this in the end, so we cannot accidentally break it off or put them together, which would create shorts again. So now I need more solder tin. Solder tin I'm using is sadly not lead free, because it is just old solder tin we had lying around. This is still the old soldering iron from my dad, actually. The one that I ordered still hasn't arrived. So yeah, I'm gonna try to not breathe those fumes in. Actually, I'm gonna try to just attach some solder to the cable itself. So that wire is also on there very, very loosely. Let's try and get it a bit more on there. Yeah, okay. That does look okay. So both of those wires are now attached, as you can hopefully see. And you still can see the black color of the capacitor, so we do not have a solder bridge between those two. Of course, we are still going to check for shorts with the multimeter. Yeah, I'm gonna put the multimeter under the camera. So into resistance mode again, and then I'm going to check for our core resistance again. and our core resistance is still 400 milliohms, which means there is no short from VCore to ground. That is very, very good, which means that our wires are attached and working. So now, because that is a very sensitive area, I'm not going to attach more solder to it. I'm now going to take some hot glue and just put it over there so nothing can short, and you also don't accidentally rip the cables off because they are very, very loosely attached. So, the hot glue gun is now ready to start. It took quite a while to heat up. So now I'm just going to flood this whole area with hot glue. Ideally you would like to use Plasti-Dip, something like that, which you can attach with a lot less slack than this. I'm also gonna take care that we cover all the open leads from the wires, and once it's not that hot anymore, you can also press down a bit, finger, so it really fills in all the gaps. And now I'm gonna So now everything is covered in hot glue, and now still gonna do another resistance check because better safe than sorry. Again, putting the multimeter here and testing for core resistance. Still 400 milliohms, that's what I like to see. So now our soldering work is done in the vicinity of the core. Now we have those two loose wire ends, which we can now attach our multimeter to. I'm also going to solder to these a bit, because again it is a multi-core wire, and I don't want those wires to get loose from each other and go all over the place. So I'm going to put a little bit of solder tin onto the ends of each wire. You can see here how it's... can we focus? Yeah, here you can see how the individual cores of the wire don't really want to go together. So that's why I'm putting on some solder. So the red one looks good. Oh, it got hot, yeah. A lot of heat coming from the soldering iron. 50 watts. And my new one is gonna be even more than that, 75 watts. I haven't burned myself yet. So that one looks good too. Alright. Another thing that you might have seen on the camera right now is sometimes the solder blob explodes and a tiny little bit of solder land somewhere, and if they land on the PCB on a very small IC, they could short those ICs out. So that's why I'm doing the resistance checks all the time. Of course, you're not always gonna be able to detect if a short happens. So if you power the card on and it immediately shuts off, that's very likely your short circuit or overcurrent protection. So yeah, if that happens, yeah, don't turn it on again, because you're gonna burn a hole into your PCB eventually. So check for short circuits when that happens. So now we have our voltage sense lines right here, and now I'm going to take my multimeter again and check the resistance of those two. Power supply box can go for now. And now we again should be able to measure the core resistance over those two wires, unless they're short together, which would be pretty bad. So I'm just gonna take those, and measurement is a bit high, probably because they're not contacting as they should. So I'm gonna take some clamps and properly attach those wires. So number one. That goes on here. And number two. And one goes to the black probe. And we have a little bit more than we measured before, because of course all those wires have some internal resistance, especially those very tiny wires. It's still gonna be fine for voltage measurements, but yeah. We have 600 milliohms now, which is not a short. And yeah, with all the internal resistance that all of these wires have that we have attached now, that should come out to our 400 milliohms or 500 milliohms yeah, VCore resistance. So our wires electrically are fine, and we can now use those two wires to measure our voltage when the card is powered up. And yeah, so let's do that then. So the card is now installed in our sacrificial test system, and here again you can see I only have one 6-pin, that's why I did the other mod. I explained why in the other video. And yeah, we have our probes hooked up, and now we can turn the card on and let's see what happens. and we can see our mod is working. We have about 900 millivolts on the core, which is completely normal for a card in boot up right now. See, the system is even beeping, so it is booting up. It just doesn't have a boot drive right now. We have no fires, no shorts. It's working. We can see there is a voltage on the core, which means our VCore VRM is working. And yeah, so that's how you do your voltage sense lines. Of course, those two should not touch ever, because if those two touch, we will have a short, potentially a fire, at least a very bad day. So yeah, I'm gonna power that one back down again. And yeah, here you have it. That's how I did my Node 2 verified working voltage sense lines for graphics cards. As you can see, it is a pretty easy hard mod compared to feedback mods that change the voltage that a VRM puts out, or maybe even e-powers, which, well, is the highest form of modification you can do for extreme overclocking. This is one of the more basic ones. This one too is pretty basic. So yeah, if you could follow this video, you are very likely capable of pulling this off yourself too. And yeah, so I hope you enjoyed watching the video. Yeah, so if this is interesting for you, maybe try it yourself. Just keep in mind, I'm not responsible for anything you break by trying to do this. So yeah, solder at your own responsibility. And so yeah, thank you for watching. Until next time, bye.